Yes,
Yeah.
I think, yeah, let's proceed.
Hiba, are we okay to go? Hiba, are you here? Okay. Okay, can you see my screen?
Yes.
Yeah.
Yes, we can.
Okay. Yeah, so for today's session, we'll be talking about operation and maintenance. We'll start with inspections that are mandatory to be done. In general, there are a lot, but I tried actually to make it more focused. Also, to make it applicable, especially for the team who is in Gaza, as requested by the team yesterday, just to make the presentation today most relevant to Gaza. Then we'll talk about some statistics in general for knowledge and about the environment impact of solar and renewable energy systems. And about the inspections that yeah. Yeah. So first thing to start with. First thing to start with for solar system is mechanical inspection. But let me ask question like, what do you think about this inspection, and when do you think that you don't need to do these kind of inspections? I will give you three options and appreciate giving your opinion about it. Like, you don't need to do this inspection if you are the owner of the system, or if you are the same installer, if you install the system, so you don't need to do this inspection after installation, or if the system is small. So when do you think that you don't need to do this inspection? Based on these multiple choices, what do you think? We are talking about installed solar system, and you want to inspect the system after installation. When do you think that you don't need to do this inspection? If you are the owner, if you are the same installer, or if the system is small, or if you have another opinion. Happy to hear your feedback.
I would say you should always do an inspection, unless maybe you have done it completely by yourself, and therefore, but even then, I think someone else should look over it.
Yeah. Any other opinion? Any other opinion?
I think anyone is concerned with the mechanical inspection maybe do this in a period of time to avoid any future problems.
Yeah. Here the point is that none of the mentioned point by myself is correct, and the correct answer is that it is a mandatory. These inspections should be done regardless who installed the system, and no exceptions. So this is important and mandatory. I think we tried to discuss about this yesterday. It is important always to separate from the design party, installation party, and the operation and maintenance party. Even if the three parties are same, one entity, one team, one group, but it is always important to separate between the scope of the three teams, and we don't mix. We don't say, okay, we installed this system, so we don't need again to inspect this at the time of commissioning, let us say. No, we have to inspect the system as we did. We are not the ones who installed it. This is very important and a critical issue. Also, even if you trust the installer doing this inspection, it is not an indication of a trust. Doing this inspection is important. It is related to the system safety, people safety, and the health operation of the system in future. So the first thing we start with after the installation is the mechanical inspection. When we do this inspection, we do it after the completion of the system installation. What we need to have with us as a documents when we handle this kind of inspection, we need to have all the project documentation. That includes the civil drawings, mechanical, electrical, wiring diagrams, layout, and so on. Who should be or who should witness this inspection? It is important and recommended to have the project stakeholders. Here we mean like the owner, the designer, the installer, in addition to the testing engineer. For some projects, you have same party, let us say, like the installer, designer, and the tester is same party. It is fine, but it is important to witness this by the owner or another party. The projects that are related to or operated under authorities, it's important to have an authority representative while doing this kind of inspection. When we talk about mechanical inspection, we mean first the visual inspection. This is something we can inspect and we can check by visually checking the system. We have a lot of stuff to inspect. We have a lot of stuff to check. I will highlight the main ones. The first thing is about the layout and configuration of the system. This is to check in general if the layout same like drawings. Remember, we mentioned yesterday that the contractor or the installer should keep updating the drawings if they need to deviate from the original design. This happens and normally happens during installation. It's fine. Sometimes the installer face some challenges at site where they need to do some changes in the design, and this is also impact the installation. But this is important to have it updated. I mean that the drawings. So this makes the next job, which is for the inspection, operation and maintenance team job, it makes it easier and it will be like direct to the point. The second thing to visually check is the substation. Here we mean the inverters, electrical systems, cables, and so on. And also to check the project documentation availability. For the documentations, we mean the documents that you will have with you while you do the inspection, which is the drawings and so on. And the other type of drawings, that the drawings should be saved at site itself. Usually inside electrical rooms and so on, it is mandatory to have a copy of the relevant SLDs and so on. This is important for future operation, and also in case of emergency, the external team who comes to take the necessary action, they need to see the actual drawings to be able to deal with this equipment. So about the layout of the system, what we check when we talk about inspecting the layout, we check the configuration of PV system. Also, we check the layout of strings, the supporting system, the structure, and so on. Also, we check the number of modules. Here, I don't mean checking the modules per string and going deeply, but in the drawings, you have number of modules shown in each row. So I mean checking the number of modules in each row. This is based on the layout. Also, positioning of the structure, it depends on the structure that you are using, if it is aligned, if it is installed in the right position, and so on. Also, the surface of the solar modules, if there is any cracks, any wrong arrangement there, and so on. For the civil work, also it is a visual inspection. We see the trenches, if there is trenches. We see the other services around the electrical room. We see the finish of the electrical room, the positioning of the main equipment, and so on. For the structure, which is under the solar modules, we check if the technical analysis is already performed, and it is something we discussed about yesterday, and one of the team requested a recommendation of software that is used for this. It is something we will check and share with you to be used in your projects, but this is important, and we'll come to the load and weight impact in another slide in this session. So you will see the impact and the importance of having the analysis, the load analysis, and other calculations done. Also, technical reports are available at site. Also, we check the condition of the support. We check the incline, if it is in line with the design. We check if it is tightened in the right way and as recommended by the manufacturer. You will see here practically how this happens. Here we are talking about simple tools that are recommended to be there with the inspector when he or she is checking the structure. You see here in the picture, it is small manual device, light device that is used to check the incline measure, which is for solar. You can check the tilt angle if it is followed by the installer, and other details. Also, you can check if the modules are at the same arrangement, at the same level, and so on. The other blue device is the one used to check the torque. You know, for each you can say whenever you have a screw and you have two parts of steel connected together, there should be a recommended torque level for each part. Sometimes it's 70 Newton meter, sometimes 40, 50, it depends on the application. And even same thing is applicable also for electrical termination points. So it's important to check this one and make sure that for structure, the torque, the recommended torque is followed. Higher is not better. Like if it is recommended to have 70 Newton meter, such an example, if you find it 80, you should not say, oh, the contractor is very good. He did amazing job, so he considered 80 more than the recommended one, which is good. No, it is not good. Actually, this will have a negative impact by time. So always the contractors recommendations to be followed, and for the structure you will have manufacturer recommendations, and also you will have the technical analysis reports that indicates about the recommended numbers or torque to be there or to be applied. Here some examples that you can discover and you can judge by just visually inspect. You see here at the right corner, the right bottom corner, you see in the picture there is a crack, and without even checking the torque, I think the clamp beside this is over tightened. So you see the impact directly on the solar module. So the crack most probably it is caused by over tightening this. You see the picture above this one, you can see how the MC4 connector is somehow thrown on ground, and even it is not connected. So it is something easy to discover. At the left side, you see a proper arrangement of cables, proper arrangement of structure. That also something you can say looks nice. You still need to check the incline, the tilt angle, and so on. But visually, at the first review, it is fine. Same thing at the left side, the bottom picture. Same thing, like at the initial inspection, it looks okay, but you still need to do the other tests. This is a continuity of visual inspection. So more inspection for solar panels. You check the alignment. If everything at the same line, you see here at the picture at the left side, you see the mismatch in the alignment. You see at the second part of the array or the row, it is not aligned with the first one. So this is something very clear. You can see even without doing any tests or inspection. At the right side, you can see an example of damaged module. This is very clear damage. You don't need to check deeply to discover it, but this is just an example. In addition to checking these points for most of the projects actually, and to make the operation and maintenance easier, most of the operation and maintenance organizations now recommend to have the modules tagged. Usually we have cables tagged, inverters tagged, the main equipment, but now some are recommending actually to have labels for modules. So you have the arrangement for the modules, you give them number. I know for small projects, this is an easy job to do, but it's a challenge actually for big projects when you have mega scale where you need to label all solar modules. This is just a recommendation, a recent recommendation actually, and it is highly recommended to make the things easy and for track and the future operation. Just in case if it is applied in the project, this is one of the things we need to check in the solar module. Yeah, the other part for solar module is about checking the cables for solar modules. This is also an example you see at the upper picture. It is something also we talked about yesterday. You see the MC4 connectors. For the connection, the cables are connected. So if someone is checking only the connection, it is connected. But if someone just asks whether if this is acceptable or not, for sure this is not acceptable. And we explained the point, and I can just repeat it quickly. You see, like MC4 connectors should not be in this position, should not be in the lower position. They have their built-in protection. There is a rubber inside where the water doesn't easily get in, but by time, as we design these projects for 20 or 25 years as a lifetime of the project, it is expected that by time and by having a water drop within the wire touching the MC4 connectors, it will happen by time. That doesn't mean it will happen at the first year or second year, but it may happen after 10 or 15 years. And when it happens, the impact actually is very huge. So it is recommended from day one to make a proper arrangement for the cables and avoid having MC4 connectors at the low level of the system, and it should be something similar to what we are seeing in the bottom picture. The last thing to check about solar module is about the nameplate. So you can say, like, before the testing and commissioning and before this inspection, we can say like there was a designer who designed the system, who did the right selection of the equipment for solar modules, inverters, sized the cables, and so on. Then another party came in, maybe purchased this equipment, followed the design, either did some changes in the design or not, but basically followed the main design and installed the system. So we cannot blindly say, okay, it is done, and we just need to have a look, and that's it. So here it's about, again, it's about responsibility. It is about health operation of the system. and it's about making sure that the system will operate as expected, and it will deliver the power for those who need it, especially when we talk about situation like Gaza and other areas where power is not only just a source of light, it is about dignity and others. So it's important to make sure that the system will continue operating properly. To do so, we have to act always independently from previous activities at site. So don't think who installed it, don't think who designed it, regardless if it is big name or unknown name. You need to check each and everything. Checking the nameplate is one of the things. You need to make sure that the installed modules are same as considered in the design from day one. And if there was a changes, this should be there in the project documentation, and it should be clear the reason for changing it. Also, if there is a mismatch, if there is any wrong module installed at the middle of the correct modules for any reason, sorry guys. Yeah, so it's not about trust or not. So maybe by mistake, one wrong module installed at the middle of correct modules. If you have 100 or 200 modules installed for multiple strings and distributed in multiple strings, all are correct except one module installed at the middle that doesn't match with these modules. This will cause a lot of problems later on. So it is your responsibility as a testing engineer to find this and to verify it. And if I'm the owner and if there is a mistake, I will first blame the testing engineer, really. If I'm the owner of a project and something wrong founded like later on after operation, the first one I will blame is the testing engineer, then I continue to the rest. But I will not blame the designer or the installer first. So this is why it's important before we say it is okay, we check each and everything, including nameplate, rating, and others. When we talk about electrical equipment, it's important we check the positioning of the equipment. Here we mean the panels, inverters, and others. We make sure that they all positioned as it should be. We also make sure that cables are arranged in the proper way for DC and AC. Also, we make sure that for the breakers, for all other equipment, everything is there as it should be. And about IB rating, so you see here in the picture about IB rating. So you can see there is a box here, enclosure for breakers with IP66. So that's fine, good. But by having a bottom look at the cable entry, you see the opening around the cable. So you see the cables there, the white cables, there are an openings there. So this or such opening, actually, it affects the IP of the enclosure itself. So as a testing engineer, this kind of work is rejected. So IP rating should be maintained. So when you purchase an equipment or enclosure with an IP rating, the IP rating was selected based on the location of the installation of this box. It is not a random number. This is a critical and it has a meaning. So it is very important to maintain this IP rating. And to do so, all manufacturer recommendations in this regard should be followed. So there is a recommendations and procedures for each of these activities that is expected to happen in such enclosures, where you need to have an openings for cables, in and out, and so on. There is also a recommendations about the material to be used here to close around the cable. Sometimes like rubbers come with the enclosure itself to be used, and so on. So this is something important to check during testing, and important to fix before proceeding to the next steps of commissioning the power plant. This is inspection for the DC and AC auxiliary systems. This is not necessary to be there in all projects, but such enclosures are there in some of the projects. If they are there, it's important to check the breakers, cables arrangements, cables termination, cable tags. All cable runs are as per the design, and the tags and labels are as per the design. For electrical equipment, other electrical equipment here, we mean the switch gears, the transformers, and so on. Also to check the wiring labeling, to check the connections if they are done in the proper way, if they are as per the design, check the breakers if they are functioning well, and so on. And the last important thing, which is about earthing. And to be honest, like, this is something I personally noticed in most of the projects, that people don't give that much attention to earthing and lightning. So this is something critical and important. Installing the earthing for solar system is not difficult, actually. It is, you can see in this simple diagram, it is just connecting the frames and so on. But this has high impact if it is not followed. So earthing is very important, and it's important to check for the modules one by one when you do an inspection, that the connection for earthing is already there. And you should not proceed in commissioning the power plant regardless what is the capacity of the system. If we are talking about 10 kilowatt system or 10 megawatt, it is same. You have a metal equipment installed at the roof or on ground system. This should be earthed, and there is a clear procedure of doing so. Yeah, so I will stop here to see if you have any questions. Any questions so far about what we presented here? Guys, any question? You can ask me in Arabic if you want, if it's about the language, but yeah. Any question about this part? About visual inspection in general? Any question, any point? Yes, Oda, you are right. It's module by module. Yeah, this is very important and critical. Okay, then we'll continue. There is no questions. Yeah, so for this part, we'll talk about some of the important tests that we need to do at site. After doing the visual inspection, that means first, just to recall quickly, we inspect the overall system. We inspect the modules. We inspect the wiring, civil work, mechanical work, and we find everything is okay. The structure is fine. All modules are okay and they look healthy. We can say that the civil work is okay. All electrical equipment are installed in the right position. IP ratings for the enclosures and equipment is okay. So everything is there as it should be, and everything is matching with the submitted drawings by the contractor or by the installer. So if we reach this level, then we need to go to the next step. So we need to inspect the stuff that we cannot see by eyes. We cannot visually inspect them or verify them. So there are a lot of tests for solar systems, and implementing these tests depends on the tools and equipment that you have available at site. In this presentation, I will highlight 3 of these important tests that should be done. That doesn't mean the other tests are not important. They are, but I'm trying just to highlight the most important tests that you need to do with the, you can say, with the basic tools that I'm expecting that they are available almost everywhere, including Gaza. I mean here by tools the multifunction meter, clamp meter, and Megger. I guess that these 3 tools or testing tools or equipment, they are there available in Gaza. So if they are there, you can do these 3 tests. If you have more tools like PV Analyzer and others, you can do more tests. And more tests, that means more accuracy and more clarity about the system. But just in case if you don't have them and you only have the 3 mentioned tools, you can do these 3 tests that I will talk about now. And in a way or another, it will give you an idea about the system situation. And also I will tell you how to judge on these results if they are okay or not. Please, you can stop me anytime if you have any question, anything. I can stop. Yeah. So this is the first test, which is the insulation of LVDC and AC connections. So insulation is very important. So doing an insulation test, it gives us an indication about the system, about the connections, if there is any leakage, if there is any scratch or touch of the cable anywhere. Sometimes you do something called continuity test. This is basic test actually that is usually done for cables to make sure that there is no cut in the cable. That's fine, but continuity test doesn't give you an indication if there is any scratch somewhere in the cable, if there's a touch somewhere at the MC4 connector or somewhere in the structure or in any other location, or sometimes an internal short in any of the modules by mistake or by accident. So this is stuff you cannot discover by continuity only, but you need to run an insulation test for the cables to do so. So to do this kind of test, you need to have a Megger. So you do an insulation test for DC. You have 2 cables. You have the plus and minus. So you do the insulation test by using the Megger, for plus and minus with earth. You apply 1000 volt DC. If you guys are familiar with using Megger, you apply it for 1 minute and then check the result. So the result will be in mega ohm. So it is about, you can say that in the insulation, it's like an indication of resistivity. If you have anywhere, if you have any leakage or any short in anywhere in the circuit, you will have low ohm readings. That means there is a resistivity somewhere in the system. So you need to work on it, on fighting this issue. If you get a number higher than 1 mega ohm, that means everything is okay, and this string or this circuit is marked okay. A recommendation for this while you do testing, if it is a small system, it is easy to handle. If it is just a few strings, it is easy to handle. But if it is big system, it's important to have some marks with you, like small tag, or in any way that you can mark the successfully tested solar modules, or sorry, solar strings. The reason for this recommendation is that, first, not to miss any part. If you just think, yeah, I will remember what is okay and not, maybe you don't remember everything, so you miss testing any of the strings, or maybe you need to redo the test if you forget if this is tested or not. And it is something not recommended in general. Like, this kind of test is important. It is mandatory and highly recommended to be done. But at the same time, it is not recommended to keep repeating it, because keep applying such voltage may affect the connectors and the cables. So in this case, this is not good. I know the voltage DC will be there, high voltage most of the time, but as you know, for solar, it is not like, it's not a continuous high voltage, so it keeps changing all the day. So there is a big difference when having a continuous 1000 volt DC all the time connected, or having a variance in the voltage. So this is why it is not recommended to keep repeating this. So the best thing to do so is to have any way of marking the strings that you test or inspect. You just mark them and then move on to the next. And don't forget to keep the MC4 connectors closed after you finished, either by using tape, or some of MC4 connectors comes with small lockers where you can just close them to make them away from dust, water, and others. The second test is the V-open circuit. This is, if you remember the test that we talked about before about solar modules, you have V-open circuit for each of the solar modules. The designers did the design, considered number of modules connected together in series to form a string. Let us say you have 20 solar modules connected together in series. Each of them is around 50 volt OC. So having 20 solar modules connected in series, that means they will form together a string with a VOC around 500 volts. So doing the test for VOC for the string, same like doing it for a single module. You need to check visually that all MC4 connectors are properly connected for the full string, and then you can use a multifunction meter that supports the expected rating of the voltage. Here, as mentioned, like if you have the 20 modules with the 50 volt connected in series, that means the expected voltage will be around 500 volts. So you need to have a multifunction meter that supports such rating. And once you have the full string connected, you can just connect the positive to positive, negative to negative, and then check the voltage, test the voltage. Here, as we know, there are multiple strings for the system, and it is expected to have more. So there is a small way to judge if the number is okay or not. It's actually not by just theoretically, you can say, adding the voltage for the or expecting that the voltage will be 500 exactly, because as we know, the 50 volt depends on STC, so the module will be able to give the 50. So what I'm trying to say is that not necessarily that the VOC to be 500 volts. So this is the correct. If it is not 500, that means it is wrong. No, the voltage might be less than this. It depends on the time of test and the situation, the weather situation at that time. So you can judge if it is okay or not by comparing the voltages for strings. So you check for string 1, string 2, string 3, and take the records. If the differences are up to 5% plus minus, that means they are okay. If the voltage for any of the strings is out of this range compared with other strings, that means you need to investigate about the situation of this mentioned string. So you need to investigate about it, check the modules, check the connections, check the MC4 connectors, and find out about the reason for this and why the voltage there is different from others. The third test is the eye short circuit. It is same thing for string. You need first to follow same procedure as discussed for VOC. You need to check the connections for the string. If all connections are okay, MC4 connectors are okay, modules are connected, everything is fine. Then you just short the string plus with minus, and then use clamp meter to check the ampere in the string. So comparison, same like VOC. You take the records for the eye short circuit for the first string, second string, third string, and so on. Then you can compare them. If the differences are within plus minus 5%, that's okay. And that means all are healthy. If any of them has a reading higher or lower than this range, that means there is something wrong. So you need to investigate about it. You need to check the connections and so on. Yeah. So before we proceed to the next, I want to ask if there is any question. Any question about this? Any question, any point? Before we move to operation and maintenance. Are these information clear? Any? Thanks, Oda.
في سؤال من المهندسة أسماء في الشات أعتقد.
What are the acceptable values for resistance and lightning protection ground resistance? Yeah, so for this one, it depends on the country, it depends on the soil, because as you know, this will be grounded at the end. But I can tell you for can say average for a lightning system, they usually ask for 10 ohm, and for earthing system up to 1 ohm. But this should not be by default applicable everywhere, but this is the common recommended values. When you build a earthing system, important to consider up to 1 ohm, and for lightning up to 10 ohm. Any other question? Any point? And if you have poor grounding system, or if part not connected, it is something also you can cover while you do the insulation test. That was the first test mentioned in the 3 tests. Yeah, the next few slides, I will talk about operation and maintenance for the main equipment. It's about the main or highly recommended practices to be done. And just for your information, as you know, like for maintenance, we have a preventive maintenance and corrective maintenance. This is for all equipment in general. But for solar, the investment always in the operation and maintenance is in preventive. So if you do cost analysis for operation and maintenance, you will see that the investment always is, or the majority of the investment and cost is in preventive. The reason for this one is that the impact of failure in solar systems is huge. It's about safety of people, safety of the systems itself, and also about the power availability, because as mentioned, in some areas, solar is considered the one and only source of power. So there are always big hopes and lives built on these power plants. So it's important to keep them healthy all the time and avoid reaching failure level. In other cases, utilities depend on solar systems, so it's important to keep them healthy and operational. So this is also an advice whenever you build or have solar system, that you give attention to preventive. If you build a budget, preventive 70 to 80%, and corrective is like around 20%. So increase the activities of preventive and make sure that everything is monitored and everything is healthy. Yeah. So for operation and maintenance, let us say for failures.
Naeem, do you have a question in the chat? How do we support the soil increase its resistance?
Yeah. Thanks for this. Yeah, Asma, actually, there are a lot of methods used in different countries where they use another material. They mix it with the soil in the area where you fix the earth rod. But in my opinion, it's better actually to depend on the soil that you have. You just increase the rod length, so you might need more rods, especially in sand area. I remember some cases, such an example in Dubai, we reached 9 meters, even more, in like for rods length, just to achieve the 1 ohm for resistivity, and to avoid using any other material, because if you use other material and mix it with the sand or soil wherever you have an earthing system, it works, but it's difficult to sustain this for a future, because this will be affected by time, by rain, water, and others. So it's difficult actually to sustain same rating after a few years. So my advice is you deal with the soil as it is, and you invest more in using more rods, or you build an earthing grid. So this will make also the earthing easier, especially in areas where earthing is challenging. Yeah. Yeah. So about the failure in the system, you know, there are different types of failure in the system. There is a failed components, as we asked at the beginning, modules, inverters, cables, and others. There is a failure of poor installation. There is a failure of poor design, or external events, stuff that you don't control directly, but you can avoid. So for the tasks of the O&M supplier or contractor, so to make the things easy and clear, we'll try here to review some of these faults, give some guidance how to avoid them, and talk about the resolution of the failure and the defects. I want all of you to have a look on this. Here some failure statistics, and you will see the components with the percentage of failure. We can see the highest one is the inverter. Then the second is the string or parallel box. This is for big power plants where you use DC combiners to arrange parallel connection. Then modules. Then we can see cables and monitoring system, almost the same range. Anyone surprised by this? Can I get your opinion or your feedback in this before we... What do you think about these percentages? Anyone surprised, or anyone was thinking something different? Guys, what do you think? Don't hesitate. Tell me your opinion. What do you think? Yeah. I remember at the beginning, some of the colleagues mentioned inverter, like some of the colleagues expected inverters that are the most failure component in the system, and this is to confirm that it's true. Let me move to the next one. That also statistics, but here is about the cause of failure. You see the 48%, which is the highest one, it is unknown.
What is mean by unknown?
Yeah, this is important thing. Yeah, so as mentioned about the recommendation of the inspections and the stuff that to be done, if you just follow the process of the project from when the project is just an idea until it is operational, and you see in between a lot of stuff happening, like design and selection by the designer, then you have the selected contractor, then you have logistics for material delivery, then people handling equipment at site, installing them, some changes happened at site, and so on. So what we tried always to focus on is doing the things in the right way. If something changed in the design, should be recorded. The design should be updated, should be communicated, this should be inspected, should not miss anything. When we say unknown, that means the team failed to find the exact root cause of the problem. And this happens when you have any part of the project life cycle, you can say, from the day when it is just an idea until the operation, it is not complete. That means there are a lot of missing stuff in between. When we say missing, we mean that not necessary actually to be something done for a reason. We don't say that any of the project parties did this for a reason, but sometimes people don't give attention to stuff that they call it minor. And if you remember yesterday, we said there is nothing called minor in such systems. Any changes, any problem, any issue should be reported, should be recorded. So this makes you can say history for everything in the project, and will be easy to track. Sometimes just changing the cable route for just a few meters different from the design. So maybe the installer think that that is fine. I just did the change because of the site situation. I found this better. That's okay, but this should be reflected in the drawings. If problem happened in this cable, the team later on will find it difficult to track this cable and find the exact location of the problem. This is unknown. So this is just an example of unknown, and there are a lot of unknown stuff that can be considered like under this category. Sometimes wrong module in between, and you will see if you saw solar systems that installed long time ago, by time the sticker that has a nameplate of the solar panel, by weather conditions, sometimes the sticker goes on. So after maybe 5 years, if you go there, you find most of them not there. Maybe one solar module was not matching with the rest of the system. It was installed there, and after some time, it causes a problem. So they cannot find that this module is different from others. Maybe the shape is exactly same, but the parameters are not same. This is something you find at the time of the first visual inspection after the project is installed. Sometimes people, like when you have same party who does the design and installation, or sometimes installation and operation and maintenance, sometimes people hesitate reporting the stuff to say that, oh, we found that our installation team did this wrong and it should happen in this way. So they don't report this stuff, and the problems happened by time, and it's difficult to solve. Not sure if I explained it in is it understood? Yeah. Okay, I found some questions here. Let me go through them. Asma answered that. Okay. We have from Oda, what do you mean by earthing grid? Here, Oda, we mean that instead of having one discharge point or one earthing point, you can build a grid. If you have a building, you can have multiple points, like multiple pits for earthing and multiple rods. Then you connect all of them together. So this is an earthing grid. It's same condition here in Gaza. If you mean the point that I mentioned about UAE or Dubai before, I think so, but the conditions are not exactly same. Actually, I guess that the soil resistivity in Gaza will be much better than Dubai, because in Dubai it's more dry, and the ambient temperature in Gaza is less than Dubai. But I mentioned it as just an example. So I guess that in Gaza it's much better. It's significant that yes, the failure of the inverter due to like the reason of failures are a lot. As mentioned, like there is a wrong design, wrong installation, sometimes overload. It's about operations. Sometimes people don't follow the preventive maintenance of the inverters, which is basically just to check the inverter from time to time, keep the fan clean, and so on. And it's something we noticed actually in some projects before. People think the inverter is just a machine and it's running all the time. It doesn't need anything, but actually it needs to be checked from time to time. And the statistics that I shared, it's about records, but it doesn't mention the exact reason for a failure of the inverter. But I'm just mentioning an examples, like why inverters fail. Yeah, the system with battery. I don't get to the point about the question here. If you mean about the failure, we don't have actually statistics. The reason for this one is that the on-grid systems are more monitored, you can say, and easy to get statistics and records about it. But the systems with batteries are under off-grid category, and they are not all monitored, and it's difficult to get any track or record for all off-grid systems. But for on-grid, it is easier. So this is why the equipment related to off-grid systems like batteries are not there in these statistics. Here, significant indicator that okay. Is the failure of the inverter due to wrong design? Like, as mentioned, for the reasons, there are different reasons for inverter failure, but here the statistics doesn't show this. So I would recommend actually in general that preventive maintenance to be followed for inverter, and it doesn't need actually that much activities, but it's important. Yeah, you see, Oda, about the manufacturing defects, it's around 7%. This is based on this statistics. That means manufacturer issue in the equipment. Yeah. So for maintenance, we should always have a plan for all equipment that we have. We build a maintenance plan for this equipment. Usually it is as per manufacturer recommendation, and also it is as per the site conditions, mainly weather conditions. So the manufacturer, such an example, will not tell you like when to clean the solar modules. It is something you can plan based on the weather conditions. The manufacturer tells you that it's important to keep the solar modules cleaned. So you can say that the period for the activities are different from site to site. Whatever you do such an example in Europe, it's not same what you do in Middle East, it's not same what you do in the desert, and so on. One of the challenges that are there in Europe is the snow. It is always a problem, and it is considered actually in the weight and the structure analysis about the snow and snow weight and so on. But it is something not considered in the Middle East. In Middle East, we consider the sand as one of the main challenges, especially when we talk about the desert areas. But it's something not there in Europe and so on. So to set the right and proper plan for maintenance, you need to consider two main factors. One is the manufacturer recommendation about the stuff that should be done, the activities that should be done on the equipment itself. And the second one is about the weather conditions. So if you get an operation and maintenance plan from any source, not necessarily to be the perfect one for your system that you have in Gaza, and also the one you prepare in Gaza for your system, not necessary to be applicable for another system, such an example installed in Egypt or in Libya or in Spain, and so on. So this is something important to consider. Sometimes if you follow any plan, sometimes you find yourself doing more stuff that are not required, or you miss an important stuff that are required for your area but not required by the party who prepared this plan for another location. For solar modules, what you need to do actually, you need to keep them clean. Don't use special chemicals. This is something, if it is still used in the market, people just use this for marketing to get like more sales for unknown material. They call them chemicals. You don't need chemicals to clean the solar modules. You just need to use water, but don't use harsh brushes that may in a way or another scratch the solar modules. For arranging this, it's recommended to do it from like every 1 to 6 months. In some locations, you need to do it every 2 weeks. Others, you need to do it weekly. So this is not a standard. It depends on the location. But it is important, the common thing between all sites, that you need to keep them clean and arrange normal cleaning, normal water, and soft brush. That's it. So other stuff that you need to do for like as a preventive maintenance for solar modules, not only cleaning, you have other stuff that you need to do, which is to check the open circuit voltage of a string of modules. You need to walk between the rows and check if there is any scratch, any damages in the solar modules. This is something you can visually see it. Check the corrosion of the structure, clamps, and so on, and doing like general test of the modules. Now, the good thing for the recent inverters is that you don't need to do this at site one by one. I mean about the open circuit and other stuff, but the visual inspection is important for cracks, damages, and so on. But I'm talking about the open circuit and other stuff. Before, it was recommended to disconnect strings and test them. Now, most of the recent inverters, actually, they have string monitoring, so you can check the strings, the VOC, the I short circuit, or the current of the string, and so on. You can monitor them from the inverter. And most of the inverters, actually, they support the remote monitoring. Most of the manufacturers now, they have an application where you can monitor your system wherever you are. So you can continue monitoring this, and even you get an alarm if there is an issue with any of the strings. So the things become easier, but it's important to know the fundamental. This is also one of the recommended stuff where you can find an internal issues in the modules. If you have the proper like infrared scan, not sure if this kind of tools available in Gaza. If it is available, it is recommended to do this at least once a year in parallel or the same time of doing visual inspection, when you just walk in between the rows just to see if there is any defects or damages. You can arrange such a test. The importance or the benefit of doing this test is to check the internal stuff of the modules. In case of any internal damage or a crack, you can easily find them. So and replace the module. Another thing related to solar modules is also to be checked annually is about other stuff that not necessary to be part of the system, like trees, other items. Maybe if it is a rooftop, maybe someone installed another or a new items somewhere in the roof that causes shade that was not considered at the beginning of the project. If you have big trees that grow and then affect the system, causes like shade and so on. So this is important to check and take the necessary action for this. So you saw like a lot of preventive stuff to be done on modules. After you finish all of this, you go with the corrections, which is the corrective part, which is basically just to replace the modules that you found them cracked or non-functional. Alan? Hello? Okay, I thought that's talking to me. Okay, same thing for wires and cables. You need to check the inverters if everything is fine, the ventilation system is okay, the fans of the inverters are okay. Sometimes you just need to replace the filters if they are not clean. Even you don't replace them directly, sometimes you clean them for multiple times before you just replace them. Check the dust and other stuff just to make sure everything is fine. This activity is recommended to be done annually. In case of anything found wrong, it is recommended to do the corrective action and fix it. This is for plan in general. This is about other accessories. Here we mean like not the electrical, I mean the modules or inverters or electrical switch gears. Here we mean the other auxiliaries and accessories that we have at the power plant. This include the sensors, and most of the power plants, especially the big ones, they have weather station that continues recording the radiation, the wind speed, and others. So this is important to check that they are functioning well, to check that they are clean, also to check if they are you can say, or the calibration certificates are still valid. If not, work on calibrating them and so on. These are recommended tools to have them available with each power plant. For small systems, I think the operators are recommended to have them so they can use them in multiple plants. As mentioned in the tests, it is recommended at least to have a multimeter, to have a meter and clamp meter. These are the three that are highly recommended to be there all the time. The rest are important. They do other type of important tests, but if they are not there, that's fine, but they are recommended. If you have an option to arrange them, it is recommended actually to have them.
You have a question in the chat from Dr. Iman. What's the procedure you follow for preventing vandalism?
Second, thank you. What do you mean, Dr. Iman? Oda, for your point, yeah, I mentioned the crack as an example, but not necessarily that the issues founded by the infrared or thermal camera, it's related to cracks. Sometimes it's like malfunctional issue. So sometimes it's a problem from the module itself. So not necessary to be, you can say, only about cracks. Yeah. Dr. Iman, but can you explain about your question, please? Okay, we may come to it better. Okay, so here when we say
في عندها مهندس نايم بعثت لي انه في عندها مشكله في الصوت.
اوكي معلش لما تكون الامور ممكن نرجع له بنهايه السيشن، مش مشكله لما تكون الامور مناسبه عندها.
اوكي.
Okay, so here when we say like failed components, what we mean by this? This is just an example. When you say about solar module that it is failed, that means insulation losses, cell cracking, glass broken, or bypass diode failure. These are the most common examples of module failure. For inverters, actually, not that much, but basically it's about failure of operation in the inverter, because most of other issues that comes in the inverter, you get them as an alarm, but not failure. Sometimes it's failure due to something else, but when we talk about the component itself, it's about like an stop operating or delivering power. Example for poor design, we have loading conditions like the load and weight not considered in the design. So this is why you see systems same like I think one of the colleagues shared it in in session 2. I remember he shared video from Lebanon. So that's an example actually for not considering the proper load. Also, like not consider like proper support for the system, the supporting system. Yeah, now this is the last part of the session. I will try to go through it quickly. I just noticed the time now. So as you know, the solar system is not an isolated. It is part of, you can say, of our life. If it is rooftop, if it is ground mount, and we can see it everywhere. So we use it for street lights and so on. So as it is part of our life, so it has an impact you can say it get infected by the environment, as mentioned for sand, rain, and others. Also, at the same time, it may affect the environment. I don't claim that they are that much critical, but it's important to know about them for now and future. So the first point of this issue is the noise. Usually solar system doesn't cause or generate noise, but the relevant equipment like inverters, especially if you have big inverters, you have fan running most of the time. It is considered noisy if it is nearby residential area and so on. It's almost negligible for small systems, but it is something to keep in mind when you design systems that you just consider this part. The DBA, which is related to noise, the DBA data can be found in an inverter data sheet, so you can check if this is noisy or if it is fine. The second part about solid waste, this is usually at the end of the project. So once the module's lifetime is expired, they have actually a harsh impact on the environment, as they help us to generate electricity from solar and to get a clean and sustainable energy. But at the same time, it is not recommended to just throw them. It is important to deal with this waste in a proper way, where they go for recycling or other healthy way, but not just to throw them in the environment. This is not recommended at all. I'm expecting that you have a lot in Gaza due to war, a lot of broken modules and so on. I suggest that as we have colleagues here in the call who work with some authorities, to try to find a way and coordinate with the relevant environment organizations to find a proper way actually to deal with this waste instead of just throwing them. The other point is about water. Here for water, we mean like the two things: using water for cleaning, where it consumes a lot, and it is highly recommended to save water as much as possible. So to decrease the water usage in cleaning, it is recommended actually to try to not apply wet cleaning all the time. You can try dry cleaning for the solar modules, and this is also recommended and used. I personally applied them with previous colleagues before in Middle East, and it works to go with the dry cleaning, and you apply wet cleaning from time to time, maybe 4 wet cleaning a year, and the rest you can go with the dry cleaning regularly, every 2 weeks, every 1 month, and it works. There are a lot of tools that can do the dry cleaning. The other part for the water, especially for the rooftop, is about the drainage. So it's important to consider a proper drainage system, especially at the raining time and so on. Also, same thing applicable for ground mount systems. It's important to consider a proper drainage system for raining water. Here are some statistics of source of damage in general. This is related to the environment in general and the impact. You see that the highest one is various. That means different reasons together. And the second one is lightning. Then it continues the rest. I need to highlight one small thing here, which is fire. You see like 2% of the failure or damage accidents caused by fire. While in the next slide, it's about the cost of this damage. You see fire, that's almost 2% as a source of damage. it causes a cost, the highest costly part.
You have a question. What are the tools for used for dry cleaning from HEPCO?
So for this one, for dry cleaning, you can use motorized brushes. They are not expensive. And as I remember, the ones we used to use, it comes a small with long stick that the operator can easily carry the battery and just handle it. Even the battery is used to operate for like 40 minutes or 1 hour. So this is actually one of the recommended tools. If you don't have access to motorized brushes, I think normal like or manual brushes can be used, soft ones. And it will not be an issue or challenge if it is based on a regular cleaning for the system. Like, don't wait until you have the modules fully dusty and then you apply dry cleaning. In that case, you need wet cleaning. But if you do dry cleaning in regular basis, they are actually more than enough, and they sustain the performance of the power plant where you don't need to have a continuous wet cleaning. Yeah. So for the loading that we talked about as one of the main issues, there are two types of load. When you do a design, it's important to consider them. First one is the dead load. Dead load is the one you can easily calculate about the weight of solar modules and other equipment that you will consider. This is called dead load. Easy, you know the number. The part that is important and causes an issue by time that usually it is you can say evaluated or misestimated, which is the one for external forces like wind, seismic, hail, and others. So these are very important, and they really cause a big damage if they are not considered in a proper way at the beginning of the project design and analysis. I know it is difficult to predict or expect. Like we don't know if there will be a windstorm after 5 years. So how to consider it? The advice for this is that if you remember the simulation session with Michelle, and that's actually there in most of the softwares, you choose usually a recorded data. Usually, we recommend to consider at least the last 20 years, the records for the last 20 years, and consider the worst case scenario. That means if you live in an area that rarely to have a windstorm, it comes every, let us say, 10 years, you will find this in the records. Maybe it happened 10 years ago. Can it happen again? Yes. What if it doesn't happen? That's fine. But what if it happens? Then your system will be safe if you consider it, and it will be fully damaged if you don't consider it. So it's important actually to go back to records, and I think there are proper records for most of part of the world. Even I remember, like in practical experience, that we could find records for an isolated areas actually about weather and so on that we considered in the design. So this is the advice. Like hail is Arabic like al-barad. So I know in Palestine we get hail, but not a destroying one in general. But it's important just not to miss this part and try to check the records for the last 20 years. If we got any strong one that may cause damage? If yes, you need to see how to consider this in your design.
We have a raised hand from Maria.
Yeah, I just want to ask, because I think these days it can be a bit dangerous to just rely on past weather data, given like that we see more and more extreme climate events every year that can't be really predicted through looking at past data necessarily. So is there a way to simulate that? Is there a way to simulate kind of like how maybe more extreme events might happen in the next 10 or 20 years and account for those?
Yeah, like the point again, like you cannot predict what will happen exactly. So we use the past, we use the analysis, the records, just to try to avoid the worst case scenario. So if something happened before, it may happen again. I can give you an example. Like 2 years ago, here 2023 in Norway, in Oslo, the temperature reached -25. And as I remember, they mentioned in the records that this happened at 1940. So even if you are designing a system, considering it 20 years, you will not get such record. But it happened. So same thing applicable for other stuff. So for you as a designer, you need to try actually to go back to records. We recommend 20 years. If you have more, that's fine, and try to avoid it. And by the way, for the load, like the mitigation for the load issue is not that much expensive at the beginning, because as you know, guys, in general, for solar systems, the structure is not one of the main costly parts. So this is the point. So if it is, let us say, for your system, if it is 10%, I think maybe adding more stuff to strengthen it, it may increase to be like 11%, but still it is not a main part of the system. If you compare this extra stuff that you need to consider to make the system safe and ready for any scenario, I think it's worth it, because the impact is too much. Yeah, so this is fire hazards. I just want to highlight some points about it. So when you install solar system at the rooftop of a building, it's important to consider these 3 points. First thing, solar and equipment should not be source of fire. So I can tell you, if everything is followed in a way how it should be, it is very rarely to have fire caused by the system. It's almost 0%. If everything is checked and it is in a way how it should be, no cracks, MC4 connectors installed correctly, everything is correct, it doesn't cause any fire. And this is the first point. So solar should not be a source of fire in the building. Second point, that if a solar system, if a fire for any reason, you can say caused by a solar system, it should not affect the building. So you need to consider this point. So that means you need to take the necessary actions in your design, where just in case if fire happens because of the system, in the system, it should be isolated from the building. The last one is about the firefighting system or precautions related to safety. The one for solar system should not interfere with the fire system in the building itself, because the precautions that should be considered for solar in case of fire is totally different from the normal fire precautions. So this is important to keep in mind when you design a system. So we can highlight them quickly. Fire should not be caused by solar. The fire, if the fire for any reason generated by solar, it should not affect the building, and the fire fighting or the precaution fire of the fire of the solar system should be separated from the building. Stuff to consider while you design a system. Fire resistance of PV module. Now I'll show you some examples that for tests of fire and the design and installation of the system. For the fire, we have 3 criteria and 3 types or classes. There is class A, class B, and class C. The highest one is class A. It is about not fire resistance, but it's about the time taken, you can say, to get a fire in case of external fire or internal fire. And then the highest one is A, and the you can say the average one is C, and I think C is the common used actually for most of the applications. You see these pictures from factory. This is the way how they apply fire to check the modules, how long time it takes, how the fire operates, and how it affects the module and so on. You see here in the other pictures. So some modules actually don't have fire expansion. If direct fire affected the module somewhere, it doesn't expand. It depends on the class. There are some recommendations that I'm highlighting here about the ways actually to for actions to be taken in case of fire. So you can consider something called manual call point. This point you can consider in case of fire. Such an example, take scenario, the first scenario. If you have fire happening at the roof, you see the manual call point. It disconnects the DC, which is the most safe one. So it disconnects the DC from the rest of the system. That means this part is isolated. When you disconnect, first you protect these items not only from fire, but also from overheating or other miscurrent flow to the system. And also you protect the rest of the system. So if you don't have a continuity of the connection, the fire may end by itself for the affected modules, 1 or 2 or whatever. But if you have the continuity of connection here, you still have high DC voltage, and you still have here high temperature because of fire. So this may help, you can say, or to increase and expand the fire. The other scenario of the manual call point is to have AC disconnection. If you notice here, like we are considering this as if the inverter is inside the building, so the manual call point is always outside, but it's important to be protected so you don't have it open to everyone who comes there, but in case of emergency, anyone can come and disconnect it. So these is like different scenarios. So the last two depends on the AC disconnection, just to protect the content of the house only. The first one depends on securing the content of the house, including the inverter if it is inside the building. This is hail. This is other stuff. Hail, we talked about it. Sandstorm. This is actual picture. You see like what sandstorm may cause. So for such scenarios, it needs immediate wet cleaning. This is for dust removal. This point is important to consider. There is something called glare related to solar modules. If you have solar modules nearby military base, airport, and others, because solar modules reflect some light, so it's important to do a glare analysis and simulation before considering a specific type of solar modules in a particular location. I know this is not something you can say important at this level in Gaza, but I'm just sharing this in future in case if you design such systems, it's important to keep it in mind. The last thing to mention is about lightning. This is also an actual picture from UAE, and you can see when the lightning happens, the impact is huge. It's important to consider lightning, especially for rooftop systems, regardless what is the capacity of the system, if it's a small system or big system. Important to have lightning system all the time. I know in Palestine we don't have lightning that much, but if it happens, actually it's important. I know for some cases it's expensive, especially if we are talking about small system. The advice here to try to disconnect the system at the time of storms. Sometimes they mention this in the forecast that they are expecting some heavy lightning. So in this case, and if you don't have lightning system installed, try at that night to disconnect the solar system, and in all way you don't have any power generation from solar at night. So try to disconnect it during night time. Just to keep the system safe and protected, and also to keep the house and house content safe. So that's it for the day. Sorry, I think we took longer than expected, but yeah, tried actually to cover as much as possible and to highlight the points related to Gaza.
We have a raised hand on the end of the session.
Yeah, I want to ask about the sandstorms, because I guess sand can also just destroy the modules, right? Because it's pretty hard and it's like these small, almost like tiny stones that can like cause damage to the panels, I guess. So what is the way to protect the panels? Is it like kind of covering it up when a sandstorm is expected before it actually gets covered by sand? Like, because I guess like if it's covered like with sand like you showed in the photo and then you just clean it, there might still be or I don't know, right? Like, is it the panel might still be destroyed?
No, I can tell you, like, it is highlighted actually first at the load and weight, because it is expected that in areas where you have sandstorms, that this may add more weight, same like hail. So it is important to consider this from day one in the design. So the structure will be capable to carry the modules even when they are fully covered with sand after sandstorm. Covering the modules actually is not practical thing, especially when you talk about big power plants, and even some cases it worsen. If you have any covers, it may get more sand and so on. So we let it, you can say, act as by their nature, and then we take the necessary action after the sandstorm to clean the solar modules. There are a lot of methods to clean the solar modules and
but is
remove
the sand
all.
destroying the surface of the module, of the panels? That's my question.
No, actually, for
Okay.
most of the current technologies, actually, solar modules, even the glass itself is being developed, it doesn't affect it.
Okay.
Yeah. Yeah. Any question, any point?
think there's one in the chat. Naim.
There should not be earth losses, Iman, if there is an earthing already connected for solar modules. So if the modules, if the earthing system is installed there, you have MC4 connectors connected in a proper way. That should not be, can say, affected by any environment issues. One of the main challenges actually I see in general is about humidity. The areas where you have high humidity, you know, it causes like, you can say, it makes the surface of the solar modules like super glue, you can say. You get, when you get sands or any other items in the air, it comes and gets stuck on the surface of solar module. So this is one of the points maybe we didn't mention, but it's important to consider it. And whenever you have high humidity day or days, it's important to clean the solar modules after this immediately. Yeah. Any other point? Any question? Yeah, so Engineer Hiba and Engineer Mahmoud, we will plan for the next phase or phase 2 of the training, and we want actually feedback from the team for this training. So
Yes,
if you
sure.
can coordinate, as we have everyone here, guys, if you don't mind for a few minutes, just open your camera, introduce yourself, give us your feedback. This part will not be published. It will be recorded for our records, but it will not be published. So don't worry. We just need your feedback, your suggestions. We can review it carefully together with the team later on, and it will help us actually to build a